All right, guys. So now, all right. You should always turn off your TV and phone when you're learning or teaching. Okay. Before we talked about when we know the population standard deviation. All right. And so when we know it, we use the Z. Right now, we don't know. Okay. So now we're going to do. Now we're going to do it when we don't know the population standard deviation. All right, so the T distribution versus before we did the Z distribution is they're similar. It's bell-shaped, symmetric about the mean. The mean median mode is 0, the center of distribution. It approaches but never touches the x-axis. All right, so this is all how it's similar. Okay, how it's different is that the variance is bigger than 1, and instead of it being one curve, it's a family of curves, and they're all based on what's called degrees of freedom. As our sample size increases, it reflects the normal distribution. All right, so here's just a little more about it. Let's compare this formula. Let's see if it'll let me. Let's compare this formula to the one we just learned. So the formula that we just learned is that Z equals X minus mu over sigma over square root n. All right, we talked about that, or we will talk about like these two specific formulas pretty in the next chapter, really. And so know that this formula, which you know that formula using the central limit theorem, and then you know this formula, x minus mu over standard deviation is the other formula, and those two relate back to this, are similar. The formatting is similar to the T distribution. All right, what I wanted you to know, though, is that the T distribution relies on degrees of freedom. And the degrees of freedom is the sample size, n minus 1. So if there's 26 things in your sample, then your degrees of freedom is 25. And this totally relates back to the fact that, remember when we did population standard deviation and we had to divide by n? And then when we had to do sample standard deviation, we divided by n minus 1. And so that's what this is that n minus 1. And so notice, so the normal standard curve is this blue one. And then if we had degrees of freedom that were different, those curves change. Let's say that the degrees of freedom was, I don't know, 6. So it's in between those two. All right, and so they all kind of look like the bell shape, but some of them get really high, some of them might get really flat. And so that's how it differs. The standard normal, the Z, is always the same curve every time. Okay, one more time. Degrees of freedom is n minus 1, so it's the sample size minus 1. Okay, we're going to have to look up some of these numbers on the T chart. And so if what we're looking at, for example, 68 is not on the T chart, you use the lower one because 65 and 70 are on the chart. So keep that in mind. All right, so I want us to find the critical value. So T alpha over 2. So before the critical value is Z, because we're using the Z chart, and it was the standard normal distribution. It was the Z distribution. Now we're using the T chart because it's the T distribution. All right, and so here's what we're going to do. you have, here's your T-chart. Okay, 95% confident, and there were 15 of them. And so you need to do 14 right there, and then 95% confident. So this 2, 2, 1, 4, 5. And so this, I'm looking up here, confidence intervals. Okay, in the next chapter, I'm going to show you how to use these two columns, but for right now, just stay here. And so right here is an example of what we just did, 2, 1, 4, 5, and just find the degrees of freedom and where the confidence, level of confidence is. And so that's your answer. So 95% of the area is going to be between negative 2.145, that z-score, or t-score, and then 2.145, that t-score. Now let's do another one. So we want T alpha over 2. We're going to have 90% confidence. And sample size is 22. That means our degrees of freedom are 21. I'm going to do 21 and 90%. I think that flies. All right, 21. So it should be right there. Yeah. All right, so that one right there. This is way easier if I had the chart like on me. 1.721. So that means that center 1, 2, 3, 1, 2, 3. So here, here. Okay, and so that means that 90% of that data is going to fall within negative 1.72 z-score standard deviations and positive 1.72 z-score standard deviations. All right, so let's put it all together. So this looks like the exact same formula as before. Look, x bar, the mean, that they're going to give us the mean, or they'll give us data. T alpha over 2. All right, for T alpha over 2, you're going to need your degrees of freedom and the different confidence levels, confidence intervals. So like if it's 90% and 10 or something, you just find where it is. Unlike before, when we had Z alpha over 2, we had those three numbers and we just went those three back and forth, back and forth, back and forth. All right, then we have our sample standard deviation. And then we have the number of items in our thing. All right, so the format and the shell is the exact same. This number is going to change, and we have to constantly look it up on the chart, and then they'll give us the other numbers. Also, this piece is still called the margin of error. Okay, that. So same basic setup here. All right, so we select. I don't want to lose my computer. Okay, we select 16 coffee shops. So N is 16. That's nice. What's going on, folks? Okay, the sample mean is 162.0. The sample standard deviation is 10. Our confidence interval is 95%. So if N, our sample size is 16, that means that our degrees of freedom are 15. And so that means our T alpha over 2, we need to do 15 and 95. 15, and 95, 2.131. All right, and then we'll use the formula. So x bar minus 2s square root n mu x plus t alpha over 2. Why do I have this memorized? Because I've taught it. Every time I go and reteach it, I always have to have it right out for me. All right, and now we'll just pop in our numbers. X bar 160. Read my handwriting. 2 minus 2.131 s 10 n square root 16. 162 minus 2.131 n square root 16. All right, so what I always do is I always find the margin of error piece. So I'm going to do 2.131 times 10 divided by square root 16. Get 5.3. Plus 5.3. All right, so we could write it as 162 plus minus 5.3 if we wanted to write the answer as a margin of error, or we could write it as an interval. So then it would be 156.7, 167.3. And that's the answer as an interval. So that means that we are 95% confident that it will be between 156.7 and 167.3. Or you could say we're 95% confident it'll be 162, give or take 5.3. That's the temperature of the coffee or the drink. All right, let's do, so how do we do this in the calculator? The thing that changes now is we're going to do the t interval before we did the z, and we just type everything as is. So let's do stat, because we're in statistics, test, go down to t interval, x bar, I'm going to do 162. Oops. 62, standard deviation was 10. There are, let's see, 16 is in, and then 0.95. All right, so those are what I get, 156, 57, 167, 33. All right, so it's right here. So let's compare that real quick, 156, 167. 156, 167. Notice. 6, 7, 33. All right, we rounded a little, so no big deal. If you're just that tiny bit off from what I got, because maybe my calculator rounds differently than you, maybe you did it by hand and I did it by the calculator, that little tiny bit is not going to be that uber important. All right, so in the next video, let's do a little more practice.